to Daily LeetCode. It is day 93. The grind continues. We have a legendary comment from Thomas Wong himself. We know this. Can't believe it's day 92 already. The grind never ends. Yay! Yo, guys, the grind, the hustle. Something about the words grind and hustle are uncomfortable, man. Maybe it's just a 2022 thing, but 92, pretty crazy, man. Me and Thomas probably been going much longer than this, but here we are, man. It's pretty crazy. I keep saying I was gonna make it was gonna be like a YouTube video, like, with a thumbnail, like, hey, this is how, X days of doing LeetCode, and I think we have to do it. Maybe I think now we have to do the day 100 video, so we'll just do that. And I should have did the 30 days of doing LeetCode video as well, but I have some notes for that, so maybe we'll just do it anyway. But we're here anyway, and yeah, I've been curious, how do people work on system design? I think that's the real question, right? We're sitting here doing LeetCode problems, and the result is binary, right? To some extent, you do the problem, you get the answer, right? Maybe it might not be the most optimal answer. Maybe it's exponential time. I'm very familiar with writing exponential time algorithms. Maybe it takes n cubed time. I'm also pretty good at writing those as well. And we're trying to get better at writing the linear ones, the actual good ones. But yeah, I don't. System design is so open-ended. Even with the Don Martin System Design Primer on GitHub, which is a great resource, by the way, it's just I'm reading the stuff, watching the videos, engaging with the content, definitely learning. I was learning today about multi-homing, which I don't quite understand yet, but hopefully get better. I definitely think I understand cap theorem better now, so that's a good thing. But the process of getting better at system design is just interesting, because it's just so open-ended. You do the LeetCode problem, you get the answer, even if it's slow. With system design, you read and engage with the material, but there's just no concrete outcome that you're making progress. I mean, you might recognize terms more, but yeah. And even the system, there are like some system design problems that you can do. Even then, you never really know if you're on the right track, because usually, you're working with someone, and you need to know, like, hey, how many requests can we expect? How the requests per second, like what's the axis we're going to be working here? There's going to be mostly read, mostly write. If we're reading, is it very infrequently? Maybe we should use cold storage. So it's just unknown. So maybe someone should make a LeetCode, but for system design. So that would be pretty cool, and that would be pretty dope. So maybe that's what we'll do. I know there's a lot of system design courses. I know there's a system design one on LeetCode. Maybe we'll work through that as well. I don't know. I'm hoping just the continued exposure in the area will help us out. But yeah, if anyone knows all that there is to know about system design, or is a master, definitely, we need some guidance. So if you know something, if you know like if you can help us break down system design, that would be pretty dope. But yeah, the Don Martin one is what we're working through, and even then, that is a legendary resource. So pretty cool. That being said, we've been working on Excel sheet column title. This problem is the hardest problem on LeetCode, confirmed. I said that last week, but this is the actual hardest problem on LeetCode. And yeah, I'm not convinced it's been solved. It says 338K submissions, but we don't know if that's true. So yeah, but we have this one to do today, so hopefully we'll get this one done. And yeah, we'll just jump into it. It's day 93, and yeah, Thomas mentioned it's to day 92, which is just crazy to think about. I didn't really think we'd ever get this far, so it's just really interesting to see. Maybe we'll get to day 300, 400. What would really be dope, I'm going to do a callback at day 5,000. I'm going to do a callback to this video. So hopefully we get to day 5,000. I'll be like 90 years old. So that would be pretty cool. But yeah, we're just gonna jump into it. Yeah, so day 93, 30 minutes on the clock as usual, and let us jump into it. So we last left off at this problem at 168 Excel sheet column title, and it seems that we're trying to return the corresponding column title as it appears in an Excel sheet. For example, we have A, right? We'd like to return 1. We have B. Oh, no, they're just mapping column title, column number to column title. So the column number 1 is A, column number 2 is B, column number 3 is C, column number 26 is Z, column number 27 is AA. And then column number 28 is A. A and B. So what we extracted from this the first time was that these column numbers on this left hand side, at least the format they're expecting, is base 26. And the reason we have to accept this, the reason I believe that this is true, is because 27, right, maps to this style. AA pretty well. For example, if we imagine the 26 symbols in base 26 to be from A to Z, right, then based on how, I forgot what it's called, but I think it's called base notation, we'd have A, which maps to symbol 1, times 26 to the 0th power, which is 1, giving us 1, right? And then here we'd have base 26 to the 1th power times 1, which is 26. 26 plus 1 gives us a decimal value of 27. And the same thing here for AB, where B would be represented as 2, like we set up here. Now there's a strange thing happening, which I think we noticed yesterday. So we have 26, right? When we have 26, the output we're expecting is actually Z. And that is very strange, because our output is A, right? And I guess another way to put this a little better, right, we should say else column plus equal 0. So this is what our number actually looks like. We have 26 places, and this would happen with base 10 as well. You know, there's not only 10 spots actually. There can be an infinite number of spots. But we're just starting 26 places out. And so for our output here, we end up just returning A. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this yet, and then here we're outputting 0, 1, 1 because our column number, our decimal number at this point would be 0, our power would be 1, and our dividend if we do 27, if we do 27, we get the correct answer. It seems to be whenever we have just a singular number, like a number that would evaluate to one symbol. Like, what if we had 52? Yeah, we expected AZ. So I think what I'm seeing here is that AZ I think what we're seeing is that AZ. The output here is why does this say 25? What is going on here? In fact, it might just be easier if we just said base equals 26 so that we're not So I think ours gives us B, which technically makes sense. Actually, no, that doesn't make sense. Oh, no, yeah. 26 to the 1th power, which is what this is saying here, right, gives you 26. And 2 times 26 does give you 52. So I think the way we're going about generating this is just not going to work. I guess another way to think about it is, would this work if we did it for would this work for base? What we're doing? Would it work for base 10? So let's say we had 52. Right? Alright, let's keep it even simpler. Let's just say we had 26. And if 26 is already in base 10, but let's just say we wanted to transfer it into base 10. With what we're doing right now, column number would be equal to 26. Or I guess what our algorithm is outputting here. Go to 26, we do 26 divided by 10 times 10 to the 26, right? And we probably wouldn't get anything that gives us a dividend of 0 until we got to the power 10 to the 1. Which we'd add 2. Alright, because 26 divided by 10 to the 1 would be 2.6, which would be 2. Alright, we'd say dividend does not equal 0, so column number equal to gives a remainder of 6. Right, we have column plus equal dividend, which would be 2. I'm going to comment this out for a second. Do power minus equal 1 to 10 to the 0, and then we'd say column number, which is 6, divided by base to the 0, which would be 1 to give us 6. And then we should get 20. I don't know, we have to change. Base to 10. Alright, so what I'm doing works for base 10. I think we're just realizing that this output is not a normal base 26. Let me see what 0 returns. Oh, so you can't even have 0. Oh, brother, this is a nightmare. soon as we go up to 26, I think this is where our problem lies. I think this is where our problem lies. I think this is where our problem lies. We have A, right, and it's saying A. It doesn't actually mean 1. There should be an extra 0 here at the end, and maybe that would be better illustrated if I did something like this instead. If we did 26 going up to including 0, each do power, minimize this. So we're just what if we just, instead of doing while till column number equals 0, because once it equals 0 and we cancel out the number, we don't actually end up with the zeros at the end. So we just want to move all this stuff into a while so we make sure we get every 0. And then we don't have to do while column number does not equal 0. And then we can just do the dividend, right? And if it does equal 0, right, we just add it to the column. We don't have to do power minus equal 1 anymore. And we don't need the power variable because it's just going to start at 26 and go up to 0. Oh, I don't think you actually can count down. So we'll just reverse it. We'll start at 0 and go up to 26. We'll just call this idx, and then we'll create a variable called power, which would just always be 26 minus idx. That's another way to count down. So this is kind of what I was getting at before, how this is an A, but it's not the A at the end, it's just the A before we were stopping at the 0. So technically this is 26 because at this decimal place we'd have 26 to the 1, which would give us 26, and 1 times 26 would give us this value, but this is not what they're looking for. It looks like 20. Yeah, I just don't understand what exactly is going on here. Maybe I'm stuck on the base 26 thing and it has nothing to do with that. Maybe what we want to do is 26. We're interested in the number 26. Maybe we should, so if we say z gives us 26, right? I know we're definitely not starting from the least significant bit, because if you were, you would say that z, right, definitely goes into 701 at least. I mean, y, the decimal value at this 0th index, which would be 1, at the minimum it goes into 701 at minimum 26 times, right? And then as you go down to the most significant digit, we'd realize that it doesn't actually get us to 701 because it's impossible to get to 701 unless we start with y here, which would be 25. So we have to be going from left to right. Maybe the way we're doing it is just weird. They're saying that 26 to the 1, which is 26. If we did 26 times 26, you get 676, which makes sense that the z is here. So it makes sense that the z is here. What if the cheat code, let me check one more thing. I think we'll have an answer if I can check one more thing. If I say 26 to the 2, we say 26 to the 3, (26 to the 1). There's something with the symbols happening, I think. We have A here, which doesn't make sense. They're using Z here. something about the base notation here is off. They're using ZY. If Z maps to 26, I think we're explicitly saying here that we're using A to Z, which is 26 symbols. So I think what I'm doing here of adding a 0 you can't do since there's no 0. Then we just get AY. (26 to the 2) I don't think we need to start anywhere near as high as 26. I think you can just do like 10 or something. I don't understand. We're getting A, which is exactly how it would work, but they want us to put Z, but it doesn't make sense to put Z. Let me try another one. Let's try another one like 7011. Let's try something like so this works most of the time. There's no way that this makes sense. What's 2 to the 30? I'm gonna see 2 to the 31. If I copy and paste this in and subtract 1, it looks like this works most of the time, right? With us being bounded by, but there seems to just be when we use just 26, they'd like us to return Z. It's pretty much directly at these intersection points is where we have an issue. We return B. Yeah, I'm so confused. But I'm gonna be honest, I'm probably gonna try this one later. We're out of time, but yeah. I'm not I think we need like a slight hint, but there's no. Yeah, we'll be back again tomorrow.